Let's get right into it, folks. Welcome to our latest explainer. Today, we are untangling a truly fascinating botanical mystery. We're looking at Avalong's Notes on Gardening, Part 887, literally just published today, May 7th, 2026. And wow, is this a story of nature behaving in ways that completely defy logic? Let's see what's going on here. Okay, let's dive into this riddle. How in the world can a plant suffer from severe dehydration symptoms right in the middle of an intensely wet season? Think about it. If a plant is practically swimming in water, the absolute last thing you'd expect it to die from is thirst, right? No way. It just defies our basic understanding of plant biology. But you know what? Nature is rarely ever that straightforward.
So to set the stage, here is exactly what Ang reported from the garden. Quote, "Even though we've been experiencing raining season for the past moons, there have been numerous downpours per day lasting for hours." End quote. I absolutely love that phrasing, right? Past moons. It really gives you a sense of just how long this has been going on. We aren't talking about a quick spring shower here. This is an entrenched, heavy, rainy season. If this were a true crime show, this weather would be the ultimate alibi. The environment is practically screaming, hey, it couldn't possibly be a lack of water. And yet, well, the evidence tells a completely different story.
Let's examine our crime scene. Despite this endless, relentless barrage of water, we've got a clear, undeniable victim in Ang's garden. The plant is suffering from something called tip burn or leaf scorch, and Ang actually went the extra mile here using AI verification to confirm this diagnosis just based on the physical state of the plant. The very edges of the leaves, they're turning brown, crispy, and essentially dying off. So the environment says flood, but the plant's actual physical condition is screaming drought. So what exactly is leaf scourge on a biological level? Well, it's basically a failure of the plant's vascular system. Think of it like a plumbing issue. The plant's internal pipes just cannot deliver enough water to the absolute outer edges of its leaves. When that continuous flow of water fails to reach the outermost margins of the foliage, that specific tissue just dries up, turns crispy, and dies off.
And this brilliantly illustrates the absolute core of our mystery. What we're looking at is a massive systemic breakdown. The reservoir outside is overflowing from all that rain, but the internal delivery mechanism, the actual pipes trying to reach the outer city limits, they've completely failed. So the big question is, if the environment is totally saturated, what is causing this internal blockage?
Based on the research and conducted into this specific garden anomaly, we can actually narrow this down. We've got exactly 3 main suspects in our interrogation room today. 3 distinct variables that could, theoretically, cause a plant's vascular system to fail like this, resulting in leaf scorch even when the skies are literally pouring rain. Let's bring them in one by one. Enters suspect number 1, water quality. Sometimes, as Ang points out, the problem isn't a lack of water at all. It's the invisible contents hiding within the water itself. When we use cap water to supplement our gardens, we aren't just giving our plants pure, pristine H2O. We're delivering a whole cocktail of municipal additions that the plant has to process through its delicate root systems, all the way up into its leaves. Let's look at the specific mineral offenders Ang highlights. First, fluoride. Second, chlorine. And third, general salt buildup, which is incredibly common from tap water usage. Here is how this crime goes down, all right? The plant drinks the water, and these minerals travel up through the vascular system. But they don't evaporate. Instead, they get pushed to the very end of the line, the leaf tips, where they accumulate and concentrate over time. Eventually, this mineral buildup hits toxic levels and literally scorches the leaf tissue from the inside out. It perfectly mimics dehydration. It's a solid suspect. Now for suspect number 2, low humidity. Usually, when the air is too dry, it can strip moisture from the leaves way faster than the roots can replace it, causing scorch. But we can actually dismiss the suspect from our lineup right away. Why? Because as Anna observed, the reality of their specific climate is that it is highly humid. The air is already totally saturated with moisture. So low humidity, completely out. Its alibi holds up perfectly, and its chance of being the culprit here is exactly 0. Now, what's really interesting about this slide is that it brings us to our final and, honestly, most likely suspect: inconsistent watering. This isn't about minerals in the water, and it isn't about moisture in the air. This suspect is all about the sheer, unpredictable chaos of the environment itself. It's about a complete failure in routine. Ang's research points to the whiplash between 2 wild extremes. On one side, extreme dryness. On the other, extreme wetness. This plant isn't just dealing with the rainy season, it's dealing with violent environmental shock. Just imagine a plant sitting in completely parched, bone-dry soil, right? And then suddenly, bam! Without any warning, it's completely submerged by hours of torrential downpours.
Here's how this builds into total vascular failure. Step 1. During those severe dry spells, the fine root hairs that actually absorb moisture physically shrivel up and die back. Step 2. Unpredictable massive downpours suddenly flood the system. But because those absorbing roots are damaged, they can't just instantly bounce back to drink up this deluge. Actually, scratch that. It's worse. Severely desiccated soil often repels water at first, causing runoff instead of deep watering. And step 3, this frequent bouncing between drought and flood causes extreme botanical stress. The plant just goes into shock. This totally paralyzes its ability to absorb water, leaving those poor leaf tips starved, despite being right in the middle of a flood.
So the crucial point is right here in Eng's final verdict. Quote, "The most possible reason is inconsistent watering, where the plant went through extreme dryness and wetness frequently, causing stress to the plant." End quote. That solves our paradox. The true killer here isn't the sheer volume of rain over the past moons, it's the erratic, chaotic delivery that completely broke down the plant's internal plumbing. Which brings us to a pretty important takeaway for all of us. Are you accidentally creating this same kind of botanical mystery in your own home? You know, it's really easy to neglect a houseplant until the soil is bone dry, and then panic and overcompensate by drowning it in the sink. But as Eng's notes demonstrate, a stressed plant can literally starve of thirst while standing right in a puddle. It really begs the question, how many other plant diseases are we totally misdiagnosing when the real culprit is just our own unpredictable routines? Something to think about next time you grab the watering can. Thanks so much for joining me for this explainer, and I'll catch you next time.